Good afternoon, everyone. My name is Stephen Silvas and my matrix number is 19638.
My name is Avinash Naidoo Saravana Kumar. My matrix number is 198543. Today, we will be presenting to you a video on how to solve the question regarding differential equation
Using real life applications.
Okay, today we're going to look at outflow of water through a hole using Orderial's law in Orderial differential equations. The question we have today, it concerns the outflow of water from a cylindrical tank with a hole at the bottom of the tank. So we have to find out when the tank will be empty. If the tank has a diameter of 2 meters, the hole has a diameter of 1 cm, and the initial height of the water when the hole is open is at 2.25 meters.
So now we will discuss on the diagram of the question. So the height of the tank, of the water tank is 2.25 meters and the diameter of the water tank is 2 meters. Now given that we are supposed to find the height of the water at any time possible and the time taken for this water tank to be empty, and given the diameter of the hole below the water tank is 1 centimeter. So now we will look into the solution and try to solve this question. So now, after discussing on the diagram of the question, now let us derive the given information from the diagram. Now we have the Orderial's law, which is Vt equals to 0.600 square root of 2ght, change in the height. So this will be the base formula that we used to solve this question. And now ht is the height of the water in the tank and g is the gravitational acceleration, which is 980 centimeter per second, or when we convert it to feet, it will become 32.17 feet per second. So using this information, we will substitute the values into the solution later to find out the answer.
Okay, we have divided the solution into 8 steps. So I'm going to be explaining the first 4 steps of the solution. So step 1 is to relate the decrease of water level to the volume of outflow of the water in a short time. Basically we're talking about the hole now. So as the volume, the rate of change of volume is equal to the area of hole times by the speed of water relative to the change in time. Okay. Now step 2, we should relate change in volume, the change in outflow, the change in volume of water. So as the water is pouring out of the hole, the volume of water in the tank is decreasing. So we are relating that to rate of change of volume in water equals to cross-sectional area times rate of change in height. Why we put negative here is because the decreasing height, so the height will be, the rate of change of height will be in the negative. So once we equate 1 and 2, which is this v equals to this v, we get this form of a solution. And then what we're going to do now is we're going to relate this to Orderial's law. So we're going to take the rate of change of height and time, and then we're going to put it together in a fraction. You can see Orderial's law over there, and we get this, which is h decrease in height over time is equals to a negative a over b, which b equals to Orderial's law. Next step is that we obtain an ordinary differential equation, a first order differential equation, and this goes dh over dt a over b times 0.6 square root 2 times 9 g, which is 980 cm height. So we derive this until we get the solution. Negative a over b 26.56 square root h.
So now we have found our first order differential equation, which is dh over dt equal to negative 26.56 a over b square root of h. So now our next step, our fifth step will be we have to separate the ordinary differential equation. So now I will move the dt to the right and I'll bring the square root h to the left, which will give me dh over square root h, which is equals to negative 26.56 A over B dt, and after that I will divide this whole equation by 2, and after integrating this equation I will get 2 square root h, where I will get the c, the constant, minus 26.56 A over bt, and then I will square this whole equation so that I can remove this square root, and then after squaring this equation and dividing it by 2, the final equation which I will receive for the height will be c minus 0.000332 t overall square. So that will be our equation for the change in height. Now we will move on to our sixth step, which is we will substitute all the given values from the equation. So now the initial height. So to find the initial height, we have to keep the time as 0. So at time 0, the initial height of the water tank was 225 centimeters. 2.25 meters, I have converted into centimeters. So I will get 225 centimeters. So when I substitute the value of 225 centimeters into the equation of C, I will get my C square as 225 centimeters, and my C, after square rooting 225, I will get 15 centimeters. Then using the value of C, I will follow up with my step 7 and step 8, which is I will calculate the time taken, and then we will recheck our given answer. So substituting the value of C into the equation of the height, I will get 15 minus 0.000332 t square, and at the height of 0, the time given to us is 45,181 seconds. So we have to convert it into hours. So after dividing by 3,600, I will get the time for the tank to totally get empty is 12.6 hours. This can be rechecked and the answer will be accurate.